Hi, everybody. Back again, 14.2 now. So, yesterday, the past couple days, it's been chemical reactions and balancing those chemical reactions. Well, now we are going to identify the types of chemical reactions. So, that's what we're looking at today. A little different than last section where we had 5 learning targets. Right now, we only have one. The difference is, with this one learning target, well, we need to be able to identify 5 types of chemical reactions based on those characteristics. So we need to be able to look at all those different types of reactions. I'll be honest, this is my favorite section of notes to teach if we're in a classroom. I should have come up with a clever way to do it here, but I didn't. You guys are going to be doing that clever way of coming up with these chemical reactions on your own. Um, but yeah, this is my favorite section of notes to teach. I usually get people all dressed up and things like that. Put on some funny costumes. It's pretty fun. Unfortunately, I'm not going to be wearing any funny costumes for you guys because I don't need to do that. I'm just going to wear a baseball hat and have these earbuds in. So, a synthesis reaction is our first type of reaction. If something is synthesizing or it's synthetic, okay, it's going to be made. It's man-made or making something. That's what synthesis really means. So a synthesis reaction is when we're taking 2 or more substances and we're combining them to build something bigger, right? We're taking an A and a B and combining them to make AB. Okay, so that's what a synthesis reaction is. 2 or more substances combine to make a new substance. They're combining. We started off with 2 and now we have 1, or we started off with 3 and now we have 1. That's a synthesis reaction. An example of this: iron and oxygen combine to make iron oxide, which is just a rust. Um, Now, I told you that this is my favorite section of notes to teach, and maybe I shouldn't go through this, but I'm going to anyway, just to kind of give you guys some ideas. But these reactions, I like to teach them with relationships. Okay? So when we go to a homecoming dance, you don't need to have have a date to go to the homecoming dance. You can have 2 people go to the dance solo, but they meet at that dance, they become friends, maybe they exchange some Snapchat info, and they leave that dance and not as a couple singles, but as a couple, that AB, right? So we had a single A and a single B, and now we have a couple AB. Polymerization is kind of a weird term, not a weird term. You're going to talk more about it in biology. It's an important term to know, but it's important not just for biology. There's a lot of uses for polymers. They're everywhere. A lot of materials that we use are polymers. And what a polymer is just a large molecule that's made from small ones. Monomers, so single, mono means one, right? So monomers combine to make a polymer. And we can just keep adding on monomers to make a longer and longer and longer chain or making a larger and larger polymer. There's all kinds of materials for this. My brother-in-law is a mechanical engineering student and just about finished with his master's, and he had to take an entire class on polymers. Um, Different materials for different things. You can see all of these different polymers down here. Polyestyrene would be like foam containers, or polyethylene, food packaging. Polyester you have in your clothes. Polyvinyl chloride is PVC pipe. Polyvinyl acetate we use in chewing gum. Great. That's polymers. So the opposite of 2 people going to the dance single and leaving as a couple is them breaking up at that dance, right? That's a decomposition reaction. And maybe they go to that dance as a couple that was on the rocks, and that relationship decomposes in front of our eyes, and they leave not as a couple, but as 2 single individuals, right? That would be a decomposition reaction. A single compound is broken down to produce 2 or more smaller compounds. Here's a couple examples of those. Water, the bottom one there, H2O breaks down into its 2 parts, hydrogen gas and oxygen gas. One thing I want to point out is that if water can break down into hydrogen gas and oxygen gas, well, hydrogen gas and oxygen gas can synthesize to become water, right? So those synthesis reactions are just the exact opposite of a decomposition reaction. It, they can go either way, just depends on the energy that we are either putting in or taking out of that reaction. Here's another example of water and the decomposition of water. So we have water in these 2 bottles here, right? And on top we have balloons, catching that water, and we have an energy source, a battery. We have a positively charged metal and a negatively charged metal, right? Now, one thing I want to point out is that the oxygen gas happens to be on the positively charged side. Now, if we think about that, why that might be, we could just say, it's probably just a random thing and whatever, it could be either way, but it's not the case. Oxygen, those oxygen molecules are attracted to that positively charged metal because when we break them apart, oxygen, remember, has that oxidation number, that charge of -2. It wants to take in some of those electrons. So it becomes negatively charged, therefore it is attracted to the positively charged metal. Hydrogen gas will have that positive charge because it can lose those electrons. It can give those away. So it's going to be more attracted to that negatively charged metal. So we talked about some synthesis and decomposition, building up and breaking down. Well, now this year, going to that homecoming dance, we have introduced another character. Okay, now it's not just a simple you find a partner or you break up at the dance. This time we have a single displacement reaction. So A had a partner, X, they went to the dance, B went to the dance, but as the dance went on, B kind of worked its way in and kicked X out, and X left the dance a single, and B left as a couple with A. Okay, a single displacement reaction. Okay, Mr. Steal Your Girl here, B came in and kicked X out of that reaction, out of that relationship, and X left single. That is a single displacement reaction. One element replaces a similar element in that compound. In this case, we have two similar elements here, iron and copper, right? Iron and copper are both metals. Chlorine, non-metal, not really similar to those ones. But iron and copper are similar. This copper chloride is aqueous. That means that it is dissolved in a liquid. When we introduce iron to it, then iron will actually react with that chlorine and kick that copper out. So now we get solid copper and we get iron chloride that is dissolved in water. So iron came in, kicked out copper, and now we get iron chloride, and copper is a single element. That's a single displacement reaction. Okay. And we can see here in this picture, the yellow just came and switched places with the orange copper. The color isn't that great on it, but you can see, you get the idea. They just switch places. The next one is a double displacement reaction. So now, again, we're not just breaking up or forming relationships. We get a little crazier. And now we had two couples go to the dance. And when they left with different partners, right? So we had A and B, and then we had C and D. But as the dance went on, maybe D and A started dancing, C and B started dancing. And you know what? That was okay with them. They left as different couples than what they went in as. An example here. Oh, it actually didn't show an example. But this is also going to form a precipitate. One of the compounds that is usually a precipitate gas or a molecular compound. So almost always going to form a precipitate. We do a whole lab where we take solutions, so compounds that are dissolved in water, and we mix them together and we see which ones form precipitates, that cloudy substance that can form in a chemical reaction. A precipitate, so this is a picture of a precipitate, and precipitate is a new solid product that comes out of a solution in a chemical reaction. So we have solution A is clear, solution B is clear, and notice when we pour them in, we get this yellow cloudy substance that you can't see through. That is a precipitate. Okay, those are little tiny solid flakes. It's not like you get a solid chunk. It's like, oh, we mix these liquids together and it just turns into a rock. Not like that. We get little tiny solid pieces that really just make the liquid very cloudy. That's what a precipitate is. And we get those precipitates from double displacement reactions. The last type of reaction, you guys see this one all the time. It's a combustion reaction. And anytime we take a carbon compound, wood, paper, things like that, propane gas, methane gas, whatever it happens to be, we take that carbon compound and oxygen and we can have a fire, right? Combustion reactions are almost always going to produce a fire. The carbon compound reacts with oxygen to produce CO2 and H2O. These are great. So combustion reactions always have a carbon compound, oxygen, and we get out CO2 and H2O. That will always be the case. Okay, anytime you see like a big C6H12O6, okay, that's glucose, that's sugar. That's what happens in your body all the time. Your body burns off sugar and oxygen, and you give off carbon dioxide and water. Those are waste products for you. So that's an example of a combustion reaction. We could also say that carbon compound could be a log. Okay, that wood is carbon based. It's a carbon compound. We need oxygen, and we can create a fire that gives off CO2 and H2O, a combustion reaction. Okay, here are a bunch of other carbon compounds and their chemical formulas: methane, ethane, propane, butane, pentane, hexane, heptane, octane, all different formulas. Those are just a couple examples of combustion or carbon compounds. There's so many more that it could be. So I think that is it. Yep, that's it for this section of notes. You guys actually have a pretty fun assignment coming up here. You guys need to try to find examples of these different chemical reactions. You guys need to make those examples, take some pictures, put them in some Google Slides and things like that. Okay. See you guys again, 14.3. I'll be back with more notes.